Okay, fine. Thank you. Yeah, very good morning to all. Okay, and today, yesterday, what we have been seeing is that we have been completed the discussion about memory management. So, in memory management, we have been covered two interesting topics: memory management techniques, and followed by virtual memory. How virtual memory concept is practically implemented is the virtual memory concept is practically implemented by using paging, segmentation, and segmentation with paging. Already we have been seeing all the particular concepts yesterday, and we have been seeing problems on how to convert address translations, and we have been seeing problems on virtual memory, and we have been seeing problems on okay page replacement algorithms, and next we are going to be see a topic of file management. Okay, and in this particular file management, we want to talk about two kinds of dimensions. Number one is how interface is going to be looks to the user, that is file system interface, and the second very important one is file system implementation. These are the two topics what we have been want to see in file management. Okay, and before going to the detailed discussion about okay file system interface, first of all let us define what do you mean by okay a file. A file is nothing but it's simply defined as it is a collection of records that must be kept it on a secondary storage device. What is a file? A file is simply defined as it is a collection of records that must be kept it on a secondary storage device. Okay, that particular information, whatever the related information you have on your hands, that particular information must be kept it on secondary storage device. Without keeping on secondary storage device, it is not going to be called it as a file. That's why I want to define what is a file system in the sense a file is going to be simply defined as it is a collection of records must be kept it on secondary storage device. So that's why before going to the detailed discussion about file concept, first of all, okay, so we must know what is okay. Secondary storage device. Most probably today all the people are using a hard disk as the highest secondary storage device which can be used in the market. Okay, so first of all, before going to the detailed discussion about file system concept, first of all, how secondary storage device, physically how secondary storage device is exists, and logically how the user will going to be see this particular hard disk. Now we're going to be see. Okay, already this concept already I covered in the last class. Already you know that. Okay, already just a brief overview of your hard disk. Your hard disk is having a number of platters. Okay, these all platters are connected through a spindle. Okay, and each and every platter is having connected to one boom, and every boom is having one reader head, and the bottom of them is going to be called as arm. Okay, and the discs are rotated in this direction. Okay, each and every platter is having surface. The each surface is connected with the read write head. So using this particular read write head, you are going to writing information. Each surface is now divided into a number of tracks, and every track is divided into a number of sectors. A sector is the smallest representable unit on a secondary storage device. A sector is a smallest representable unit on a secondary storage device. It is going to be called as 512 bytes. This is so what is in we have been saying. This is a physical structure of a secondary storage device, that is hard disk. Now coming to the logical structure of coming to the next very important one, logical structure of your hard disk is you're going to be simply your hard disk is divided into a number of partitions, and each and every partition is a collection of directories, and each and every directory is a collection of files. Each and every directory is a collection of files. Each and every directory is a collection of files. Now, this is what we have been seeing in the last class. Now, coming to the today's concept is that number one, coming to the first one, file concept. Okay, how do you demonstrate this particular file concept? In the sense, we're going to demonstrate by using five different dimensions. Coming to the first one, what is a file? A file is simply defined as it is a collection of related information that must be mapped onto a secondary storage device. Okay, let us take an example. Okay, or you can technically define it as a file is a collection of records. A record is a collection of fields. What a field is a conceptual tool for representing data. A field is a conceptual tool for representing data. Let us take an example. Suppose your hall ticket number 101 is one field. Your name, something Likita, is one field, and your age, something 20. Okay, that is one field. Collection of these particular three fields belongs to one record. Okay, so a field is a conceptual tool for representing data. The collection of these particular fields is equal to one record. Collection of these particular records kept it on a secondary storage device is going to be called as a file. The files may be of different categories. It may be a source files, or it may be an object files, or it may be an executable files, or whatever it may be. There are several different kinds of files are there. Okay, source files in a sense. Okay, in case if you're doing C programming, all the files are extension with .c. In case if you're doing C++, all the files are going to be extension with .cpp. And if you're doing an MS Word document, all files are extension with okay, or docx, whatever it may be. Okay, these are object files. Okay, they're extension with .obj and executable files. This is mission independent optimizer code, and this is mission dependent optimizer code. Executable files in the sense mission dependent optimizer files are going to be called as executable files. Okay, these are different kinds of files are there. Now, how do you understand the file concept? The file concept is going to be demonstrated by using the following 5 parameters. Now, coming to the first very important one is file attributes. Coming to the first very important one is file attributes. What is a file attribute? Okay, so whenever the user has been, already we have been already we have been covered the various responsibilities of an operating system in connection with file management is creation of files, deletion of files, creation of directories, deletion of directories, searching of a particular file, repositioning of a particular file, increasing the size and decreasing the size, repositioning a file. Everything is the responsibility of an operating system. These all operations are going to be done with respect to fact table. Already we have covered this particular topic in the third topic of our discussion, that is operating system structures. And that is what we have been seeing is that okay, now fact table, file allocation table. So what is the file allocation table? So file allocation table is simply an indexing for the entire secondary storage device here for hard disk. Okay, so similarly, so how we are going to be picking a page in a book, whenever you want to retrieve any particular topic from a book. So first of all, you're searching an index. Wherever the topic is found in the index, the corresponding page number is picked up, and simply you're reading the content from there. That's enough. In a similar manner, whenever the user want to retrieve any particular data from the secondary storage device, that is on the hard disk, first of all, you're looking into fact table, and fact table simply determine whatever the file that is going to be you are referring, that file is available in which platter number, which track number, and which sector, and how many sectors it has been. Okay, so that is fact table. In a similar manner, created any particular file, the entry has to be made in fact table. Suppose if you want to remove any particular file, first of all, you have to remove that particular entry from the fact table. That implies, in case if you try to make any particular modifications on a file, the changes must be reflected on fact table. Why? Because a fact table is going to be simply acting as an index for your secondary storage device hard disk. Okay, is it clear, everyone? Now, depending on that, now we are going to see that file concept. This is already we have been covered in operating system structures. These are the various responsibilities of an operating system in connection with file management. And coming to the next very important one is file attributes. The first very important topic is file attribute. So whenever the user has been stored any particular file, what are the different kinds of attributes that are associated with the file? These all attributes are going to be stored in fact table. These all attributes are stored in fact table. So first of all, let us will see what is what are the different kinds of attributes that is associated with the file. Now, first of all, whenever a file has been created by the user, so first of all, it creates what is the name of the file and what is the extension of that particular file. That is, what is the type of the file, whether it is .c or .cpp or .doc, .docx, what type of the file, where this particular file has been originally stored, that is location of the file, how much size it has been occupied, that is size of the file, protection, who is eligible for accessing this particular file. So every file is going to be accessed by users, owners, and then something. There is different kinds of permissions. That is a separate topic of Unix. Okay, it is not our discussion now. So protection information, when the file has been created, when the file has been lastly updated. Okay, who is the user which has been created for this? These are the different kinds of attributes that is associated with the file. So whenever the user has been created any particular file, these all attributes are going to be stored in fact table. These all attributes are going to be stored in fact table. These all attributes are going to be stored in fact table. That's it. This is the different kinds of file attributes that are associated with the file. And coming to the different kinds of operations that can be performed on a file. Okay, now the different kinds of file operations you are going to be performed on a file is that number one, coming to the creation of a file. So what do you mean by creation of a file? Simply you are allocating a space for a particular file. Okay, so once the space has been allocated, where it has been allocated, these all entries must be done in fact table. Why? Because the next day the user comes and he asks for that particular file, you need to search and you need to open the content and you need to show in front of user. That's why, so creation of a file in the sense, simply allocating a space and the secondary storage device and make an entry in fact table and make an entry in fact table. 7. Similarly, write. Suppose if you write any particular content on a file, okay, so automatically once you have written a content of the file, the size of the file automatically it increases. So that how much size it has been occupied, it should be recorded on your fact table. That is right pointer or something. Now, suppose if you want to read a content, so how do you read a content from a file? First of all, you are searching that whether the file is available in the hard disk or not. You are going to be searching in fact table, and in case if it is available in, so it's simply written you which in which platter and which track number, how many sectors it has been. It simply written that question. And reposition within a file. Suppose if you copy the contents of one file from one place to another place, suppose if you want to move the file from one particular location to another location, what you need to do is that you need to change the entry in fact table. Why? Because your fact table is simply making as an index for entire your secondary storage device. So that implies, okay, if you want to delete a file, how do you delete a file? Simply you can go to the fact table, okay, and make a valid bit as an invalid bit, and whatever the space it has been occupied by this particular file, and ask him to add to free space. That's enough. This is simply that implies whatever the operations you are going to be done on a file, this all operations has to be reflect the changes in fact table, reflect the changes in fact table. This is going to be referred as file operations. Truncate, you can truncate a file, you can open a file, you can close a file, every operation. Whenever you want to do any particular this operation, first of all, you have to make a request to the operating system and to check whether this particular file corresponding information is available in fact table. If it is available, simply get it and show in front of you. That's it. These are the different kinds of file operations what you're going to be right. And one important point in this, okay, once we got and get one question we got here. So what is this particular one? Open file count. Okay, we have got one question, call it as open file count. What is open file count? Open file count in the sense. So open file count. If the number of open file count simply tell you that how many number of files which has been left open. Okay, how many number of files are already open. So before shutdowning any particular system, first of all, you please try to see that open file system count should be 0. Otherwise, the system is not allowing you to shut down the system. Shut down the system. This is what happened. So open file count is an attribute which will simply tell you that how many number of files. Suppose let us take an example. Suppose you have been opened 3 or 4 files and you are directly click on shutdown. Immediately tell you that sorry, some files are left open. If you forcibly stop them, it has virtually shut down the system. Whatever the content which has been already not saved, it will be simply lost. It will give you. That why it asks him to save all the files, then the file count becomes, close every file, that file count becomes 0, then only it allows you to shut down. Otherwise, it is not allowing you to shut down. Okay, and today modern operating systems, you are also having a new option, force shutdown. So force shutdown in the sense, forcibly shut down, close all the files by yourself. Okay, the content may be saved, may not be saved, and automatically. This is what is needed. So open file maintains open count. That is number of users accessing this particular file. Okay, open file count is also used for another purpose. Okay, open file maintains open count. How many number of people are accessing this particular file? There are several pieces of information associated with this open file. What is this one? What is a file pointer? What is a file open count? And disk location of the file. These are the different parameters which are associated with a particular file. Already I told you that okay, pages can be shared and segments are also be shared. And I told that pages are all going to be shared, segments is also going to be shared. One segment can be shared by any number of processes at the same time. Suppose if the same segment is going to be shared by multiple users at the same time, suppose if you are going to be forcibly shutdowning it, it tell you that these are the number of users accessing this particular file. So before shutdowning that, you please try to see that if any inconsistencies which are going to be happen. That is what is file purpose. And coming to the next very important one is file types. What are the different kinds of files? The files may be executable files, and that is those files which are extended with the .exe, those files which are placed in bin directory while installing the software, and those files which are going to be already placed in .com. These are all comes under the category of executable files. Object files. There is machine independent optimized code files. That is .obj, .o. These kind of files are going to be called as object files. And the next one, source files in the sense .c, .p, okay, .f7, .cpp, .java. These all files are comes under the category of source files. And batch files, three or more commands are grouped into one particular file, which is an extension of .bat. This kind of files are going to be called as batch files. Okay, and text files. Normally, whatever you have been typed so far, .txt or .doc, these are all text files. So on to like this, library files, .lib, something, so on to like this. Now coming to the next one, file structure. Okay. Or files may be stored in encrypted fashion. And the files can be accessed by user in two manners, in SQL action or direct action. This topic is already done. So, and again, we'll have a detailed discussion about on this in just a short while. And finally, the last one is going to be called as internal file structure. The last one is internal file structure. So actually, I told you that this particular file is internally stored in so what platter and which track and how many number of blocks or sectors it may be occupied and how much size it has been occupied. So then you know that what is a track, a sector, sorry, you know what is a sector? A sector is the smallest representable unit on a secondary storage device which is of 512 bytes. Which is of 512 bytes. The collection of sectors is equal to block. So in order to improve the speed, of a read-write head, we'll go for a block organization. What is a block organization in the sense? A block, first of all, let us will define what is a block. A block is a collection of sectors. So let us take why the people are went to block organization. Why the people are went to block organization. Suppose your reader, suppose the sector size is 512 bytes. The sector size is 512 bytes. Let us take an example. Your read rate had having a capability of reading 2000 bytes at a time. Suppose if you are going for a sector addressing scheme, what happens is that by using a single read call, you are specifying only one sector address in the address bus. So by using that address, you can read only one sector at a time. The sector capacity is only 512 bytes, but your read rate is having a capability of reading 2000 bytes at a time. Then what happens is that, okay, nearly 1500 bytes of reading capacity of read-write head is going to be simply wasted. In order to improve the fastness, then we group the 4 sectors into one block. Then we go for a block addressing scheme. By specifying a single block address, you can at a time read 4 sectors of information at the same time. That's why we always prefer block addressing scheme. Collection of these blocks is equal to track. Collection of these sectors is equal to one platter. Collection of these platters is equal to your hard disk space. This is what is going to be called as this one. So we'll get a problems on this. Okay, how many number of platters is going to be required to store this file? Each file is having this number of records. Each record occupies like this. This is formulas is required. Just simply you know that what is a sector? A sector is a smallest representable unit on a secondary storage device which is of 512 bytes. Collection of these particular sectors is equal to one block. Collection of these blocks is equal to one track. Collection of these particular tracks is equal to one platter. They simply specify the platter is divided into 20 tracks. Each track is having 20 blocks. Like this, they have been given every information. So in order to store this particular file, okay, how many number of platters is required, or you may ask that how many number of blocks is required. They ask like this. So that depending on the question, you can do it. There is no formulas for this. You can directly do it. It is a normal mathematics. Now, coming to the second very important point of discussion is that file access methods. Now, once the contents has been stored on a secondary storage device, once the contents has been stored on your secondary storage device, what are the different ways of accessing the particular contents from the secondary storage device? What are the different ways of accessing the particular contents from the secondary storage device? The various ways of accessing this data from secondary storage devices is the following techniques: serial file organization, sequential file serial access method, you may call it as serial. You can also call it as this one is file organization techniques, or you may call it as file structures. You know, okay, you know what is a structure? A structure is nothing but it is a method of representing data. A structure is a way of representing data. Okay, how the data is going to be represented so that the different kinds of operations on that particular data is done in very efficient manner is going to be called it as structure. The structures are mainly classified into two categories. Number one is data structures. Number two is file structures. Okay, what is a data structure? A data structure is simply defined as it is a logical and mathematical model of organization of data in main memory. It is a logical and mathematical model of organization of data in main memory is going to be called as data structure. And a logical and mathematical model of organization of data in secondary storage devices is going to be called as file structure, a set of techniques which can be used to store the data on secondary storage devices so that the insert, delete and search operations must be done in very efficient manner is going to be called as file structures. Okay, so already we got one question on GATE examination. How the question is, so what is the distinguishable operation while storing the data on secondary storage device? So we are giving most of the importance for only searching, not for insert, delete. But whereas in the case of data structure, we are giving importance for all the three operations: insert, delete and search. But coming to the file structures, we are giving importance for only searching. Okay, so what is the most distinguished feature must be considered while deciding a file structure technique? In the sense, you need to write search. Don't answer is given as like this: insert, B, delete, C, search, D, all of the above. So in case of data structure, you need to give answer all of the above, but in case of file structures, you need to give C, that is only searching. Now, what are the different kinds of file organization or file access techniques? So this is serial access method, or you may call it a serial organization method, sequential access method, direct access method, indexed access method, indexed sequential access method, hashing, so on like this. We have different kinds of techniques out there. Now coming to the first very important one is serial file organization, or may call it a serial access method. So what is this particular serial access method? The data is going to be stored according to their arrival order. So how the data is arrived, so that the data is going to be stored in the same manner. That's enough, simple logic. So first of all, you first record, second record, third record, fourth record, so on, and whatever the order they have been arrived, the file is going to be stored according to that order only. Now, once you have been stored the data in serial access method, okay, suppose any one person comes and they tell you that retrieve this particular record, then how many ways are there? Only one way is there, linear search. So using linear search technique, you are simply searching for the record and simply retrieve it and give it. That's it. This is how it is going to happen. So you know what is a linear search? A linear search is a process of searching for an element sequentially, location by location is called as linear search. That's it. What is the time complex for accessing a record in a serial access method? Order of n, where n is representing number of records in a file, where order of n is simply defined as number of records in a file. That's it. Suppose whatever the records which has been arrived to the file, if the file has been arranged the records in a sorted order, then such kind of an access method is called as sequential access method. In a sequential access method, the file records are going to be stored in sorted order. So Now, once the records are in sorted order, if you want to retrieve any particular record, you can use binary search technique. So binary search is a simple technique how you are going to be picking up a page in a book. In a similar manner, we are going to be using this particular sequential access technique. Let us take an example. Suppose a book is having 400 pages. Each page is having a page number, but the pages are not in sorted order. Suppose I'm asked you to pick up a 72 page. How do you pick up? You'd see the first page. The pages are not in sorted order. Clearly mentioned this. First page, you see it. It is not 72. Second page, it is not 72. Move it. Third page, it is not 72. Move it. Like this. You are going to be searching for every one page. Like this. This kind of an access method is going to be called as serial access method. Now, if the book pages are already in sorted order, how do you pick up the page 72? First of all, you're open in the centering page. Why? Because the pages are already in sorted order. By seeing the center page, you are getting 200. That implies the page is just in the first half, not just in second half. So for a single comparison, I can eliminate half of the pages. Again, I will make it half in the first half. Again, I get 100. That implies whatever the page I'm searching 72 that is available in the first half. Again, and the second half is eliminated. Like this, you are going to pick up the time complexity for retrieving this kind of a method is going to be called as log n to the base 2. Log n to the base 2. But you have one small condition here. So whatever the file you are trying to make a sequential access, all file records must be kept it on main memory. So before performing a sequential access, first of all, you please try to bring all the records in main memory. Otherwise, binary search cannot be possible. In order to overcome this particular, this is a second very important one. This is a second very important one. And coming to the next very important one is that, okay, next one. So in order to bring the entire file into main memory, it consumes a lot of memory space. If the file is consists lakhs of records, is it possible to bring the entire file into memory? Sorry, our main memory is not having that much of ability to hold all that number of records. So then what we are going to go is that the next very important one is we'll go for index access technique. Meanwhile, just leave the third one, direct access method. We'll see at a later stage. Now, indexed access method. What is this index? That implies every file is going to be stored in the form of two files. Every file is going to be stored in the form of two files. Number one is index file and second one is data file. The data file contains the original records, how they are going to be arrived. According to the arrival order, the data is going to be stored. So where this particular each and every record has been stored, the record key value and the address of the record has been kept in index file. Simply how we are going to be making an index in a book in a similar manner, we are making an index file. That index file simply contains only entries with two columns. The first column specifies what is the record key value. Second one is what is the address of this record value, where this record has been originally kept on it, like this. Now what happens is that whenever the user wants to search for a particular record, the entire file should not be bring it into main memory. So we can bring only the index file. Okay, only index file should be bring up into main memory and make a binary search with the complexity of log n to the base 2. Then you can find the address of that particular record and go to the secondary storage device and you can read it. This kind of a technique is going to be called as indexed access method. This kind of a method is going to be called as an indexed access method. Okay, and after that, suppose if the index is also too large to hold in memory, then what you're going to do? Then we go for indexed sequential access method. Then we go for indexed sequential access method. What is this particular indexed sequential access method? So, indexed sequential in the sense we'll store in the form of the top records is going to be stored in the form of blocks. Block 1 contain all the records from 1 to 100. Block 2 101 to 200. Block 3 201 to 300. Like this you have been stored. In index file, how we are going to maintain it? The records from 1 to 100 is stored in block 1 address, and 101 to 200 is stored in block 2 address is this, like this. So whenever you're requesting for a particular record, suppose I want to retrieve 150 record. I want to retrieve the record number 150. How can it? So first of all, 150 lies between 1 and 100. No, 150 lies between 101 and 200. Yes. And what is its block address? And go there, simply sequentially search for your record and retrieve it. This kind of an access method is going to be called as indexed sequential access method. Okay, and this is also can be implemented by using B trees or B plus trees like this. Okay, no problem. And coming to the last one, which is direct access method, or may call it as hashing. Both are same. So where the searching of a particular record is always done with the time complexity of R of one. Okay, already we got one question in examination. Okay, how do you get a question in this? Okay, in which kind of file structure technique? So the we're going to be give you with a time complexity of order of one, that is hashing. And what is hashing? You already know that hashing technique is already done in your data structures. Okay. Hmm. Nikita, okay, data structures. Okay, a hashing is a small function. It transforms your key values into a physical address where your record is originally placed on your secondary storage device. So where searching is always done with the time complexity of order of one. That's it. So that's why in this particular topic you need to remember the time complexities. In this you need to remember time complexity. Now coming to the next very important one is directory structure. Okay, so before going to the detailed discussion about the directory structure, so first of all, we'll see already just now we have been seeing that the physical organization of secondary storage device and logical organization of secondary storage device. The physical organization is already I told you. The physical is a hard disk is a collection of platters. Each platter is a collection of surfaces, and each surface is having collection of tracks, and each track is divided into number of sectors or context blocks. And coming to the logical view of this one is a disk is going to be divided into number of partitions, and each partition is a collection of files and directories. Okay, so your hard disk is divided into number of partitions. Each partition is a collection of directories, and each directory is a collection of files. Now, um, now before going to the detailed discussion about the rest of the things, we'll see the disks are going to be available in the market in two ways: unformatted disk and formatted disk. Unformatted in the sense it is going to become as a flat surface. So it is the responsibility of the user to divide the entire space into number of tracks and sectors. This is going to be called as formatting. Generally, okay, this particular formatting concepts is going to be earlier people will well know, but today people somewhat doesn't know. Okay, formatting is nothing but simply dividing the entire hard disk space into number of tracks and sectors. This is what we do. So technically, we'll talk what do you mean by formatting in a sense, creating a fresh fact table. So technically, we can define it as what is formatting. Formatting is nothing but simply freshly create a fact table. That is. So each partition, so now your hard disk is divided into partitions. So C partition, D partition, E partition, like this you're dividing. That each partition is called as mini disks, or may call it as slices. May call it as, and each file system known as a volume. A volume containing file system, a volume, each volume containing a file system also tracks that file system, an information device directory, and table of contents. This is already we have been covered all these particular topics in fact table. Already we have been covered in fact table. So once you have been created a fresh fact table, the fact table simply contains the information about how many tracks are free and how many sectors are free, how many blocks are occupied, everything is going to be there. Now this is the physical structure of the hard disk, which is already discussed earlier. Now the logical structure of hard disk is the hard disk is divided into number of partitions, and each partition is a collection of directories and as well as files. Okay, this is partition A, this is partition B, this is another partition like this. That's why I have been defined as a hard disk is a collection of partitions, and each partition is a collection of directories and files. Now, so coming to the first one, the different kinds of file operations associated with a directory. So now that I have given a title, call it as a directory structure. Yes or no? So already you know that what is a structure? A structure is a way of organizing the data so that various operations on that particular data must be done in a very efficient manner is going to be called as structure. Yes. Now I am calling as directory structure. What do you mean by directory structure? How the files are organized. Each directory is a collection of files or directories. Everyone is agreed? Each directory is a collection of files or directories. How files and directories are organized in a directory, how the files are organized in a directory, so that various operations on that particular directory must be done in very efficient manner is going to be called as directory structure. How the files are organized in a directory, how the files are organized within a directory, so that the various operations on that particular directory must be done in very efficient manner. So then you can ask me, what are the various operations that can be done on a directory? The various operations already we have been seen. The various operations you can perform on a directory is searching for a particular file. Okay, searching. So what is this definition? How the files are organized within a directory is going to be called as directory structure. How the files are organized within a directory so that various operations on that particular directory must be done in very efficient manner is going to be called as directory structure. The various kinds of operations on a directory structure is number one, searching for a file. Number two, creation of a file. Number three, deletion of a file. Number three, display all the files in a directory. And if you want to rename the content of a directory and display all the files or list the directory or call it as traverse. Traverse is nothing but each and every file at once is going to be called as traverse. Okay, these are the different kinds of operations that are associated with a file. These are the different kinds of operations that are associated with a file. Already I told you that these are all file operations are associated with pattern. Okay, now coming to the next very important one is that how the files are organized within a directory, which is called as directory structure. There are 5 different types of directory structures which is available today for use. Number one, single level directory. Number two, two level directory structure. Tree structure directory structure, acyclic graph directory structure, general graph directory structure. We'll see one and now. Now coming to the first very important one is single level directory structure. Coming to the first one, single level directory structure. So that implies the word itself, it says that only one level of directories are eligible in each partition. Okay, only one level of directories. Only one level of directories are allowed on each and every partition. That is, in one partition, you have cat directory, bow, okay, and a, task, data, this and each and every directory is internally having the files. So only one level of, within this you cannot eligible for another directory. Only one level of directory structure is allowed. So within that you can have only files. The main disadvantage of this particular files is that this kind of technique, all files are contained in the same directory, which is easy to support, understand, and easy to understand. The limitations of this is that unique file names. You should give a unique name for every file. So two files cannot have a same name within a same directory. Okay, and the length of the file is also limited in early days. Okay, so in case if anyone is aware about MS-DOS, Microsoft Disk Operating System, in Microsoft Disk Operating System, the maximum number of characters that can allow to name a file is only 11 characters, and Unix you can give the name up to 255 characters. Already we got a question and get what is the maximum length of name of a particular file in Unix. That you can give up to 255. They have that is, and the name is this one. And after that, we'll go for a two-level directory structure. After that, we'll go for two-level directory structure. So in two-level directory structure, in each partition, up to two levels of directories are allowed. So separate directory for each user. You have some user one is having a separate directory, user two having a separate directory, user three is having separate directory, so on up to like that. Each user can have separate subdirectories within the directory. There is no problem. This is we can call it as master file directory. This is user file directory. Okay, this is two-level directory structure. This is two-level directory structure. It solves the problem of name collision. Why? Because suppose if your two files want to have a same name, you can put them in one. One file in cat directory. You can put another file in some another directory. So that you can have solve the problem of name collision. And it is very efficient for searching. Why? Because if user two is searching for a particular file, we need not search it the entire this one. You can search it in only user two directory, so not in everywhere. So that the searching is very efficient. So that this is very efficient. This is called as MFD, master file directory, and this is UFD. This is user file directory. Okay, the isolation is an advantage when the user are completely independent. Okay, isolation is a very good advantage. The user is completely independent, but the disadvantage when the user want to cooperate on some task. Suppose if the users want to share any particular data among them, so it may be a problem. Okay, some disadvantage when the user want to cooperate on the same task and access another files, which is not going to be possible. Okay, and some systems do not allow a local user files to be accessed by other users. Then you need to set all permissions and something. You need an additional mechanisms. Okay, in case if any data want to be shared by two users, okay, you need a separate mechanism. This is what is going to be called as two-level directory structure. And coming to the third very important one is tree structure directories. What is tree structure directories? Okay, tree structure in the sense you can allow any number of levels. You can allow any number of levels is allowed. So now you see in a root directory, so in a root directory you have three directories: spell, bin, programs. Under spell you have another three directories, and this directory is having another three directories. In this directory you have one file. Under mail you can have so many like this. Any number of levels is allowed. This kind of a directory structure is going to be called as tree structure directory. A directory, or may call it a subdirectory. Okay, you can call it as directory or subdirectory, contains a set of files or subdirectories. A directory is simply another file, but it is treated as a special way. So in Unix operating system, the directory is also treated as a file, but the last bit is extension with one, and those files with not extension with one, that is all treated as files, and those files with the extension with one are going to be called as subdirectories. Okay, that is we will discuss in Unix operating system. Is not our topic now. And very important thing in this is that you need a special system calls for creating a directories and deleting a directories. Okay, so you need a special system calls to be used for creating and deleting a directories. In this, they have been invented another new point is going to be called as let us will see. So if you want to delete any particular directory, first of all, the directory should be empty. Otherwise, you cannot eligible for deleting. So in case if you want to delete any particular directory, first of all, the directory should contain 0 files. The directory should not contain any files at all. So first of all, remove all the files, then delete the directory. This is eligible. So whenever you want to delete a directory in this technique, so first of all, directory must be empty. First of all, directory must be empty. And they have been invented another very important one is absolute path and relative path. Absolute path in the sense from root to file. Suppose let us take an example. Okay, I want to access this particular file. How I can come here? Under root, spell. Well, again, under spell, again you have a mail. Under mail, you have another directory going to be called it as prog. Under prog, you have another directory called as list. That is file. That is, you are telling from root to the file every directory that is called as absolute path. Suppose you are already currently in prog directory. Then how do you tell? Under list, this file is there. Only you are telling from current to destination. From route to destination is called as absolute path. From current place to destination is going to be called as a relative path. Okay, and you have one time we got one question in GATE. Which file which file containing name and location of all executable programs? Which file contains okay, which file contains name and location of all executable programs? That is answer is A, B, C, D something. You have answer is desktop file. Answer is a desktop file. The desktop file is containing name and location of all executable programs in your computer system. Now coming to the next very important one is, now we can see the disadvantage of this file system is that when you want to move from this place to this place, again you need to come back, you need to come back, you need to come back by pressing the commands, call it as cd dot 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 dot, like this. You can come back and you can come here. You cannot eligible for directly jumping from one particular path to another path, one direct branch of a tree to another branch of a tree. Now coming to the next very important one is acyclic graph directories. Acyclic graph directories. And earlier we have a small disadvantage. If you want to copy from one location to another location, what happens is that, suppose let us take an example. This is x.txt. If the same file you want here, then what you need to do is that you need to copy from this place to this place by using copy command. Then you have one copy here, one copy here. So both are same. Suppose let us take both are read-only files. What happens is that the same copy of information is available in multiple places. Unnecessarily the space is wasted. So in order to work on this one, next they have been invented a cyclic graph directory. First of all, they have been given a concept of shared directories and shared files concept. A shared directory or file will be edges in the file system two or more places at once. Then a shared file will exist in the file system in two or more places at once. A shared file cannot be same as two copies of the file. One file is going to be shared by multiple directories at the same time. Okay. Okay. And to have different kinds of names are there. This guy named with one and this guy named with one, and that is called as aliasing. You know what is aliasing? Okay. What is aliasing in the sense giving an alternative name is going to be called as aliasing. Aliasing is a concept of giving an alternative name for the file is called as aliasing. Suppose what happens if the single file is going to be shared by two directories at the same time. If any one of the directory has been deleted in this particular file, what happens? Then this particular guy is pointing to a file, but the file does not exist. Then such kind of a thing is called as a dangling pointer. What is dangling pointer? A dangling pointer pointing to a memory location. Okay, it is pointing to a file where the file does not exist. Okay, a dangling pointer is a pointer pointing to a file, but the file does not exist. Okay, then what is the solutions for avoiding these particular dangling pointers? So you can use back pointers so that we can delete all pointers, variable size records of the problem. Okay, we'll put back pointers. And back pointers using daisy chain organization, you can do it. You know what is daisy chain? Already dealt in computer organization. And you can also hold a count solution, hold count solution. So if you want to delete any particular file, the hold count must be 0. Otherwise, you are not eligible to remove a directory. Why? Because it is carried by multiple users. You can use such kind of a. Now, and coming to the next very important one is new directory entry type. So now in the modern operating system, we have a link concept, which is giving you another name to an existing file. Okay, this link can be so there's a link can be a pointer that is pointing to another existing file. So resolving the link is follows the pointer to locate that particular file. Okay, this is the new technique what we are going to be using. Now coming to the last very important one is general graph directory. So one serious problem in acyclic graph directory, you know what is an acyclic graph? A graph without any cycles. The one serious problem with acyclic graph directory structure is that you must ensure that there is no cycles in the graph while constructing a directory structure. While constructing a directory structure, you should ensure that the system does not cycle. And the primary advantage in acyclic graph directory is relatively simple of algorithms to trace a graph and to determine where there is no more references to the file. Searching is very fast in acyclic graph directory structure. But you want to avoid traversing on shared sections of acyclic graph twice. Mainly the performance reasons. In order to improve the performance of acyclic graph directory structure, we should avoid traversing of shared sections of a graph twice. It should be eliminated. That is the first very important way. Okay, so it should be wasting of time. If cycles are allowed to exist in the directory, likewise, we want to avoid searching any component twice for reasons of correctness as well as its performance. So searching cannot be done twice. And deleting a particular file, remove all symbolic links and delete the file. That's not simple, it's all. And it is also having garbage collection concept. It simply collects all, you know what is garbage collection? It's simply collecting all the unused portions of areas and store it in somewhere. Whenever a new space is required, the new space is supplied from this garbage bin. But if the new space is not available, then it will go for a fresh memory location. So that is garbage collection. It is mainly used for avoid external fragmentation. You know what is external fragmentation? External fragmentation is a concept where the total amount of memory is available, but it is not in a continuous fashion. Hence, the user cannot able to run the program. This kind of a concept is going to be called as external fragmentation. So, in order to avoid that, we can use general graph directory. This completes our discussion about file system interface. This completes our discussion about file system interface. Now we'll go for file system implementation. Now we'll go for file system implementation. We'll go for file system implementation. So we have been seen about file system interface concept. Now we'll go for file system implementation. What is this particular file system implementation? Okay. Now before going to the detailed discussion about implementation, why you have been chosen the hard disk for storing your files? Why? Because the reason number one, disk provides the bulk of storage on which a file system can be maintained. That is the first one. Number two, the second reason is that it is a random access device. You know what is random access? You can access anywhere in the hard disk at the same time. And the third very important reason is that it is a spooling effect. Simultaneous peripherals operation online, which is having simultaneous peripherals operation online. Okay. Now, the only one small disadvantage, you cannot call it as a disadvantage, small limitation is that I/O transfers from secondary storage device to main memory is quite slow. In order to improve I/O efficiently, in order to improve I/O transfers between memory and disk, instead of going for a sector organization, you can go for a block organization. That's why the disks are performed in the units of blocks. all disk transfers are in the form of blocks. All the disk transfers are in the form of blocks. So what is block organization? Now we'll see. Now already I told you that the sector is the smallest representable unit on a secondary storage device. A sector is the smallest representable unit on a secondary storage device. The sector is the smallest representable unit on a secondary storage device. Okay, if you go for a sector organization, the capacity of the read write head is going to be wasted. So that's why collection of sectors is going to be called as one block. Let us take a small example for understanding of the students. Now the first line is you can read it as file system implementation. Yes. Why you are not reading as FILE space SYSTE? Okay. Why you are not reading by character by character? No, it is not. Your mouth is having a capability of recognizing these words at a time. Yes or no? Okay, that's in a similar manner. If your read write is having a capability of reading a more number of bytes. Suppose your sector size is only 512 bytes, but your read write head is having a capability of reading 2000 bytes at a time. Can you group it? Can you group it? Yes. So now 4 sectors are grouped into one block by specifying a single address on address bus. Okay. By specifying a single address on address bus, he can read 4 sectors at a time. Okay, that's why we go for a block addressing scheme. That's why we are going for a block addressing scheme. Okay, and disks are more attractive. Disks are more attractive because of the reasons is it is a rewritten capability. You can write any number of times on the disk, overwrite, overwrite, overwrite. Number 2, it is already I told you that it is a direct access in nature. So these are the 2 points you need to be kept on this mind. So finally, why the people are today choosing only hard disk as storage device? In the sense, number 1 is natural access is direct access. It can have a capability of storing bulk of information, and it is rewritten capability, and it is having this pooling effect, that is simultaneous peripherals operations online. Now, the file system where it has been resides. Already you know these are the basic points. Already everyone knows that the file systems are resides in secondary storage device, that is on the disk. Provided to the user interface to storage, mapping logical to physical. All logical information is going to be mapped onto the physical storage. The file system is responsible for mapping the data from main memory to secondary storage device. All the logical file system contents are physically mapped onto secondary. And it is file system is also providing efficient and convenient access. All file systems provides efficient and convenient access to disk by allowing data to be stored and located and retrieved easily. Provides efficient and convenient access to disks by allowing data to be stored and located and retrieved easily. That's and the next very important, disk provides in place rewrite and random access. Okay, so all IO transfers already I told that all IO transfers are performed by using block organization. Now, the storage structure consisting of information about a file. The storage structure consisting of information about a particular file is going to be called as file control block. Is going to be called as file control block. Already you know that the file control block contains information related to that particular file. Information related to that particular file. And the you know what is a device driver? A device driver is a small program that knows how to control the status and clock bits of the specific device. Okay, the complete device operations are going to be known to only a device driver. So before utilizing any component, hardware component on your computer system, first of all, you need to install the device driver and indicate the operations of the device driver to our operating system. Not only your operating system recognize your device. Now, coming to the first topic of discussion is that file system organization. So, file system organization. Now, before going to the detailed discussion about file system organization, Okay, before going to the detailed discussion of file system organization, a file system has two different design problems. How to design a file system so that how the people will look this particular file system. The first problem is defining how the file system should be looked to the user, first of all. Why? Because these all features has been created for the purpose of convenience of the user. That's why the first very important one is that, okay, the first problem is to define how the file system should be looked to the user and what are the various operations which can be allowed. What are the different kinds of attributes associated with the file? Number two, that you need to define a proper data structures to map the logical file system into physical file system. To map the logical file system into physical file system. These are the very important two things you need to be kept on your mind while constructing any file system. Now, before going to the detailed discussion about this particular file system concepts, now, whenever the user has been trying to store any particular data on a secondary storage device, that is on hard disk. So, how it is going to be stored? What are the various programs which are involved while storing the data on a secondary storage device? Now, let us take. So, first of all, whenever the user wants to store any particular data on a secondary storage device, first of all, he's open a file. That is in maybe Notepad or WordPad or a doc file. That is MS Word file. This is going to be called as application program. That is, first of all, application program is creating an environment for the user to enter the information. So whenever the user wants to store any particular data on a secondary storage device, first of all, you have to invoke an application program. Through an application program, this application program create an environment for the user to enter the information. After entering this information, then this application program internally invokes logical file system. Suppose whenever you have been issued save, once you have been issued a save, then it is asked you the logical file system to be run. By running this particular logical file system, the logical file system asks you where you want to locate this particular file, where you want to save this particular file. That implies it simply displays a directory structure. It simply displays application program is creating an environment for the user. Logical file system simply displaying a directory structure where you want to locate this particular file. Suppose you haven't chosen a particular path for storing this particular file and you clicked on save. Then what happens? Then it internally calls file organization module. The file organization module simply determines, in order to store this particular file on the secondary storage device, how many number of physical blocks are going to be required. Okay, that is how to convert a logical file system into a physical file system. In order to convert a logical file system into a physical file system, how many number of physical blocks are going to be required, that is going to be determined, and conversion of logical file system into physical file system is going to be done by file organization module. Once it is determined, then it internally calls basic file system. Now, using basic file system, you are issuing a command for it as a write. So now you are writing the intervention onto the hard disk. Then basic file system contains a command write. Suppose if you are reading the data from the hard disk, the basic file system initiates a command read. Now in this particular case, we are issuing the write. And after that, it calls IO control. What is IO control? That is called as device driver. This device driver program knows that how to write the particular data onto secondary storage devices. Okay. Now, once device driver has been taken this charge and it is successfully recorded, and the information is going to be recorded on that table. Okay, information is recorded on that table and it is stored. This is how it is going to be happen. This is, and whenever you want to store any particular file, so an application program is creating an environment for to enter information. Logical file system simply displays a directory structure where you want to store the file, and file organization module is responsible for converting physical logical file system into physical file system, and basic file system is responsible for issuing read or write, An IO control system is responsible for originally writing the data onto or reading the data from secondary storage device. In 1 year, we got a great question. Okay, number one, application programs. Number two, logical file system. Number three, file organization module. Number four, basic logic. Okay, basic file system. And right hand side, it create an environment for the user. Okay, converting display directory structure like this. They have been given and match the following. So you need to match application program, environment, logical file system, directory structure, file organization module, determine the number of blocks and converting logical file system into display file system, and basic file system is responsible for issuing read or write. Now this is, now already you know what is open file table. Open file table simply contains what are the list of files which has been opened. That is, so whenever the user want to, okay, shut down it, first of all open files has to be closed. Then it will allow you to shut down a system. This is also known as open file count also. Okay, you already know that mounting. What is mounting? It is a small terms. The operating system mounting is nothing but simply writing the data onto the hard disk. So mount point in the sense where you want to write the data onto secondary storage device. That is a pointer. That is mount. Mount point. Now coming to the next very important one is allocation methods. So whenever you want to store any particular data on a secondary storage device, first of all you need to you need to determine how many number of blocks are required and how these blocks are going to be allocated. Okay, so the main problem is to how to allocate a space to these files so that disk space is utilized efficiently, and the very important is files is accessed very quickly. Already I told you that the searching is the most frequent operation that is associated with file structures. So the main problem, so the main motor behind allocation method Yeah, can I start now? Okay. Now, again, due to technical problem, again, we'll go for the allocation methods. Okay. Now, the main problem of an allocation method is that how to allocate the space to these particular files, which should be stored on secondary storage device, and keeping in mind how fast, how efficiently we can access this particular content. This is allocation method. The main problem is to how to allocate a space to this particular file so that disk space is utilized very efficiently and files can be accessed very quickly. So whatever the amount of number of blocks which is going to be required to store your files, the blocks may be allocated in three manners, either in form of continuous allocation, linked allocation, indexed allocation. And coming to the first one, continuous allocation. So in the continuous allocation in the sense, how many number of blocks which is going to be required to store your file, that particular blocks must be allocated in a continuous manner. Now we observe it, my hard disk is having 32 blocks, then addressing with 0 to 31. The count file is started at 0. It requires 2 blocks, 0 and 1. And TR file is started at 14. It requires 3 blocks. That is 14, 15, 16 is occupied by TR. Mail is a file which requires, started at 19. It requires 6 blocks. 19 to 24, which is taken by mail file. And the list file is occupied in 28 to, that is from 28, it requires 4 blocks of information, that is 28 to 31. And F is a file which is requires 2 blocks of information, started at 6, that is 6 and 7. Like this, whatever the number of blocks which is going to be required to that particular file, okay, that particular files are going to be allocated in a continuous manner. That is allocated in continuous manner. Now coming to the, and each file occupies a set of continuous blocks. The performance wise, it is very efficient. Why? Because whatever the number of blocks which is mapped for this particular file are in continuous place, so that you can read the particular content very fast. Now, so you require only the starting address and number of blocks which is required to form. Okay, required to store this particular file. These are only 2 things is sufficient for accessing this particular file. Number 3, and the third one, the next one. The main problem is how to find out. The main problem is how to find out the space for a particular file. So in order to find that particular one, we have 3 methods: best fit, worst fit, and this one. This is already discussed. And knowing the file size. And second very important one is it suffers from external fragmentation. You already understood what is external. Now here you have 4 blocks free. Your have is 6 blocks free. Okay, like this you have. Now I want to store a file. The file requires 10 blocks. But 10 blocks are not continuously available. 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3. So we have only 6 blocks are continuous, but I require 10. What I need to do? So I cannot store this, but according to continuous allocation, whatever the number of blocks which is going to be required, the blocks must be in continuous fashion. This is called as external fragmentation. The required number of blocks is available, but it is not in a continuous fashion. Hence, the user cannot able to store that particular file. It is called as external fragmentation. In order to overcome this, we need to use fragmentation. We need to use compaction technique. So, by using compaction, you can move all blocks at one side and make all empty holes at one side. This is what is going to be done. Next, there are three kinds of allocation methods: best fit, worst fit, first fit. First fit in the sense sequentially scan all the memory holes. Wherever you have been found a sufficient number of blocks is available, you please try to store that particular file in that area. Number 2, best fit. Wherever you have been causes less fragmentation, internal fragmentation, store that particular area. That is called as best fit. Wherever you have been found large number of blocks, then please try to keep it in that particular area. That is going to be called as worst fit. Okay. This is continuous allocation method. This is continuous. And this algorithm, continuous allocation, is suffers from both internal and as well as external fragmentation. So let us take an example. I hope that suppose a file requires three blocks of okay, four blocks of two blocks of information. A file requires two blocks of information. Okay, each block having capability of 2000 bytes. Okay, each block, suppose let us take an example. Each block capacity is 2000 bytes. A file requires 3500 bytes to be stored. In order to store this particular file, you require two blocks. First block, you have 2000 bytes. Second block, you have only 1500. 500 block is 500 bytes of information in this block is waste. This cannot be used for any other one. That is internal fragmentation. It is the smallest memory hole which cannot be allocated for any other process to be stored. Already we have been seeing that the required number of blocks are available, but it is not in a contiguous fashion. Hence, the user cannot able to run such kind of a process is known as external fragmentation. This is already been happens. Now, coming to the next very important one is that in order to overcome this particular problem, next we have been comes with a new technique is going to be called as linked allocation method. It simply solves the problem of continuous allocation. Okay, you know what is a linked list? A linked list is simply defined as it is a collection of nodes, and each and every node is consisting of minimum two parts. The first one is information, second one is a pointer pointing to the next node. Second one is pointer pointing to the next node. Now, okay, now the disk blocks, whatever the empty blocks are there, it is scattered over the hard disk. Then how can you store? Now let us see. It is in the form of a linked list. The first file is started at the file name is G, and it is started at 9. And after information storing, information is not sufficient to hold here. The next one is okay, started at 9, and the next one is 13. So okay, here it is not displaying as 1. It is wrong. You please try to mention it as 13 here. And after going 13, it should have 1 here, then 1 here. After 1, okay, the information is mapped to 2, and after that it is going to be, this is 25, not 2. This is 25. This is 25, not 2, and this is minus 1. This is indicating that. Okay, so while is ended here. Okay, each and every block contains information pointer pointing to the next block. Each and every file is containing information pointer pointing to the, okay, fine. That's it. This kind of storing is going to be called as a linked list allocation. Clearly, you can understood that there is no external fragmentation for this. Why? Because, okay, you can map the files in the form of linked list. The disadvantage is that the major problem with this linked allocation method is that okay, only sequential access possible, random access is not possible. Why? Because if we go for a first block, then only you knows that where the second block is. If you go for the second block, then only you knows that where the third block is. Like this, only direct accessing capability has been failed. Another disadvantage is that you are using more amount of space for storing pointers. You are using more amount of space for pointers. So the space occupied with the pointers is simply wasted. And the third one is that another problem is the reliability. Suppose if any one of the pointer is failed or lost, the entire file content is gone. Okay, so another problem is that reliability, since the files are linked together by pointers and it is scattered all over the disk. If any one of the file pointer is lost, the entire disk, the entire file is going to be lost. Now, brief about this. The files and are ended with null pointer. Each block contains pointer. Each pointer points to the next block. There is no compaction and external fragmentations are required. Free space management system is called whenever a new block is needed. Okay, whenever a new block is needed, you need to call free space management. It allocate one block, and then you need to make a link on it. So if you improve the efficiency by clustering the blocks, but increases internal fragmentation, you already know what is internal. So it is the smallest memory hole in a block which cannot be accommodated for any other process for storing. So reliability can be a big problem. If any one of the pointer is lost, the entire information rest is going to be lost. Okay. Now, coming to the last kind of allocation method is going to be called as indexed allocation method. What is this indexed allocation method? So, where your file is going to be stored, how many number of blocks which has been occupied, all block addresses are going to be kept in first block. Suppose let us see the G file is located in index block 19. 19 plus is that the following file contain, the file G file contains are located in 9, followed by 16, followed by 1, followed by 10, followed by 25. Okay, this is how simply we can store it. So each file has its own index blocks of pointers to the data blocks. These are the number of pointers are going to be stored in the first block. Okay, and it needs an index table. The random access is possible and dynamic access without any external fragmentation. Okay, but the overhead of maintaining index block is quite, you need additional mechanism for maintaining index. You need an additional mechanisms for maintaining index block is required. So one time we got a question. Again, they have in left hand side, they are given 3 points: continuous allocation, linked allocation, indexed allocation. Right hand side, they have been given points, ask them to match the following. So depending on the points, you need to match it. Okay, that's it. And coming to the next very important topic is that free space management. Next one, free space management. So what is this free space management? So file system maintains a free space for a list of tracks or blocks available in the hard disk. Your file system is responsible for maintaining which parts of the hard disk is full, which parts of the hard disk is empty. Your operating system is responsible for keep track of which parts of the hard disk is full and which parts of the hard disk is empty. Now, in order to maintain this kind of a thing, we have 4 methods. So whenever you want to store any particular file, first of all, you need to find out where the free blocks are available. That implies your operating system must be keep track of which parts of the hard disk is already full, which parts of the hard disk empty. That is, which blocks are already filled and which blocks are not filled. In order to maintain such kind of a thing, we have 4 methods. Number 1, bit vector method. Number 2, linked list method. Number 3, grouping method. Number 4, counting method. These are the 4 methods what we have available for maintaining free space management. So coming to the first one, bit vector. Suppose let us take an example. Your hard disk is having 32 blocks. That is a number from 0 to 31. So if the block is filled, each block is represented with a bit 1 if it is free. If it is empty, then it is filled with 1. If it is already filled, then it is filled with a 0. Let us take, I am assuming that the disk is having 32 blocks, where 2, 3, 4, 5, 8, 9, 10, 11, these are the blocks are free. Then what you need to do is that, so 0th block is full, first block is full, second, third, fourth, fifth are now empty, 6, 7 are filled, and the next one, these are 4 blocks are empty, 8, 9, 10, 11 are empty, so on up to like this. That's enough. You need to maintain a 32-bit vector. You need to maintain a 32-bit vector. The main advantage of this free bit vector method is it is very simple and efficient. It is very simple and efficient. But the only disadvantage is that whenever you want to perform any operation, this entire 32-bit vector has to be kept in main memory. Why? Because this 32-bit vector must be always reside in main memory. If the main memory only 32 blocks your hard disk, 32 vector suppose. Now your hard disk is, today hard disk is 500 GB, 1 terabyte, so on like this. So that is, we have a large number of blocks are there. So that entire vector has to be kept in memory, and maintaining becomes very complex. That's why the disadvantage of bit vector method is that the entire vector has to be kept in memory. In order to work on this one, next another scientist has been invented a concept of linked list method. What is this linked list method? So you know what is a linked list. The total whatever the free blocks are there, all free blocks are going to be maintained in the form of a linked list. You know what is a linked list? A linked list is simply defined as it is a collection of nodes, and each and every node is consisting of minimum two parts. The first one is information, second one is pointer pointing to the next node. Like this you are maintaining. Yes. Now we'll see, observe in this diagram. The first free block is 2, and after that the next free block is 3, next free block is 4, next 5, next 8, 9, 10, 11, 12, 13, 17, so on like this. All free blocks are going to be maintained in the form of a linked list. Okay, so next one. Cannot get a continuous space easily. Suppose if you want a continuous space for a particular one, you cannot get easily. No waste of space advantage. You know not to traverse the entire list. Okay, whatever the number of blocks is required, please try to allocate in this sequential manner like this. Okay, this is a linked list method. And third very important one is grouping method. A modification to the linked list to store all addresses of next n-1 free blocks in the first free block. That is how you store in the sense. Now you see 2, 3, 4, 5. How many blocks are now? Free 4 continuously. Now you note down in the second block 4. That implies from here onwards we have continuous 4 blocks are available. The n-1, that is n-1 continuous free block addresses, n-1 continuous free blocks are going to be stored in first free block. How many number of continuous free blocks are available? Please try to keep it in. So modify the linked list to store of next n-1 free blocks in the first free block plus pointer to the next block that contains free blocks 1. Sorry, small. Okay, whatever I told now it is counting method. And the main disadvantage of and the next one. After counting method, we have grouping method. So this is grouping method, or you may call it as it is an index method. n-1 continuous free blocks are going to be stored in first free block. That's all. And counting method is that n continuous free blocks addresses are going to be stored in first free block. This is going to be called it as counting method. The free page list has entries containing addresses of counts. And this is directory implementation, which is already done. The directories can be secondary storage structures. This is secondary storage management. The last topic of discussion for your operating system is that secondary storage structure. You may call it as secondary storage management. You may call it as secondary storage management. Now, already we have been covered about the disk structure. The physical structure of the disk is already you know. A disk is a collection of platters. Every platter is having a surface. Each surface is divided into number of tracks, and each track is divided into number of sectors, or may call it as block organization. Now, disk provide a bulk of storage for a modern computer systems today. That's why we are always using disk. And second, some of the points which is not covered in the earlier, we'll see now. The disk rotates at a 60 to 250 times per second. The disk is internally rotates 60 to 250 times per second. And second very important thing is that we need to define one very important term, call it as disk access time. One important term is going to be called as disk access time. What is the disk access time? The time it will going to be taken to access or store the content on a disk is going to be called as disk access. It's going to be called as disk access time. This access time is a collection of three components. Number one, seek time. Number two, rotational delay. Number three, transfer time. The seek time. The time it is going to be required to move your hand from current track to required track. Sorry, current is okay. The time it will going to be required to move your head position from current cylinder to required cylinder is going to be called as seek time. Once a head is moved to the required track, you must wait until the desired sector will going to be comes. Okay, the time it will going to be taken for moving your head position from current track to required track or current cylinder to required cylinder is called as seek time. The time it will going to be taken to move your head position from current sector to required sector is going to be called as rotational delay, or may call it as a latency time. And after that, the time it will going to be taken to access or store the data from main memory to your hard disk is going to be called as transfer time. Collection of these three components, transfer time, seek time, rotational delay, is combined together is going to be called as disk access time. Combined together is going to be called as disk access time. And another very important point you need to know about a disk. If a head crashes, the results from a disk head making contact with the disk surface. That is, you will get a bad sectors. Disks can be removable. Okay, disks can be easily removed and replaced. There is no problem. And you know that this point, the disks are always random access devices. Disk is internally uses block organization. At a time, in order to improve the efficiency of a read-write head, in order to improve the efficiency of access time, so that we use block organizations. Now, a small formula you should know. Okay, for determining the block number, the conversion of a disk. Already I told that this is a small formula. Already I told that collection of sectors is equal to one block. Collection of blocks is equal to one sector. Sorry, collection of sectors is equal to one block. Collection of blocks is equal to one track. Collection of tracks is equal to one platter. Collection of platters is equal to your hard disk. Okay, that is what I told. So the conversion of a disk address cylinder, disk address of a cylinder I at surface J and sector is K, then one dimensional block number is equal to K plus S into J plus I into T, where S is the number of sectors per track and T is the number of tracks per cylinder. That's it. Is it clear? Now, coming to the next one, disk scheduling. Coming to the next very important one is disk scheduling. What do you mean by disk scheduling? Whenever multiple jobs are arrived to the disk, whenever multiple jobs are arrived to the disk at the same time, how can your read-write head can schedule the jobs? Your read-write head can having a capability of doing only one job at a time. Whenever multiple jobs are arrived at the same time, so how can you decide that? Okay, that is called as disk scheduling. So which job is first, which job is next, third, fourth, so on up to like this one. Okay, this disk scheduling algorithms are completely based on disk access time. Already I told that disk access time is a sum of seek time plus latency time plus rotation delay. The time it will going to be required to move your head position from current track or current cylinder to required track or required cylinder is called as seek time. The time it will going to be taken for the head position from current sector to required sector is called as latency time. The time it will going to be taken to transfer your information or to read the information from the hard disk is known as rotational delay. So whenever an IO operation is encountered, the IO operation may be from operating system, or it may be from system processes, or it may be from user processes. So the disk IO operations maybe comes from either from the operating system or from system processes or from user processes. Then what is IO request? The IO request may includes input-output operations. You need to discount the IO request includes whether we are performing reading or writing, where you are reading or writing, disk address, From where you're bringing that information or where you're going to be storing that information in main memory, how many number of sectors you're going to be transferring or reading from the heads. These are the information along with an IO request you need to mention. One, here you got a question. Whenever the user, an operating system or a system process has been specified an IO request, that IO request includes whether you have a input output operation, B disk address, C main memory addresses, comma number of sectors for the answer, D all of the above. Answer is all of the above. Now, operating system maintains a queue of requests per disk. Every IO device, already I told you in the topic of 4, that is process. Each and every IO device maintains one queue. Okay, your disk scheduling algorithm has to be take one job from the queue and execute it. Okay, now what are the different kinds of scheduling techniques are there? There are 5 kinds of scheduling algorithms are there. There are 5 kinds of scheduling algorithms are there. That is first come first served scheduling, shortest seek time first scheduling, scan scheduling, scan scheduling, look scheduling. These are the 5 types of scheduling. These all algorithms we are going to demonstrate by taking a problem as an example. I'll tell you all the problems related to this one, how to calculate the number of seek moments which is required on each algorithm. Now let us take first come first served. The term itself, it says that which job is going to be arrived in the queue first, and please try to execute that particular job first. That's why it is named as first come first served. Let us take an example. My hard disk is having 200 tracks, that is numbered from 0 to 199. My hard disk is numbered for totally 200 tracks. Each and every track, the numbered from 0 to 199. So one process requesting for read in information on from 98. Another process is requesting for perform an operation on 183. Another one is want to write an information on 37 the track. So on up to like this they have been given. So one person want to make an operation on at 98, another one 183, another one at 37, another one at 122, so on up to like this. So initially, currently the head is pointing to a location 53. Initially head is pointing to location 53. Now you need to calculate total number of head movements. So they ask you how many number of head movements is required to perform to clear this particular queue. Now initially, totally there are 200 tracks, that is ranging from 0 to 199. And initially your head is pointing at 53. Now the first job is 98. First of all, first come first serve, you are doing 98 job. Please try to observe this graph. After 98, your second job is at 183. So you are moving from 98 to 183. And after that, you have a job at 37. From 183 to you are moving to a 37, and you've done this job. And after that, the next job is at 122. Then you are moving from 37 to 122. You've done the job. And after that, you are moving to 14. You've done this job here. After that, you're moving from this place to 122, 124, and after that, you are going back to 65 and 67. This is how you are going. First comes observed. So now total number of head movements, that is initially from 53 to you are moving to 98, 98 minus 53, and after that you are moving from 98 to 183, 183 minus 98, and so on up to like this. So you calculate the total number of head movements is how many? 640 track movements. This is, they ask you how many number of track movements if the jobs are scheduled by using first come served scheduling, then it is going to be 640 tracks. Number 2, second one, shortest seek time first scheduling. So which job is going to be taking less seek time? You know what is seek time? The time it is taken to move your head position from current track to required track. So which job is needed for you? Please try to execute such a shortest seek time first scheduling. Now you please observe it. So initially your head is at 53. The next job is whether you are very near to 65 or 37. Subtract 53 minus 37. It is how much? 53 minus 37. It is 16. And 65 minus 53. It is 12. So that 12 is very nearer. So that I can execute 65. And after that, which job is nearer? 67, which is only required 2 track movements. And after that, whether 37 is nearer or 98 is nearer. So 67 minus 37, it is only 30 tracks. 67 minus 98, it requires 31 tracks. So the nearer job is 37, so that I move to 37. And after that, the 14 is very nearer to them. And after that, the next nearer one is 98, next one is 122, 124, so on up to like this. So the total track movements is initially you are at 53. That is now 65 minus 53, 67 minus 65, and after that 67 minus 37, 37 minus 14, and after that 98 minus 14, 122 minus 98, 124 minus 22, 183 minus 124, all combined together, you're getting total number of track movements is 236. Okay, shortest seek time for scheduling. Of course, whenever you're doing a shortest seek time for scheduling, it may always causes a starvation. In order to overcome the starvation, you can use aging concept. What is aging? Continuously adding priority for waiting processes. Okay, this is already done. Now coming to the next one, scan scheduling. So coming to the next very important thing, scan scheduling. So what is scan scheduling? The disk arm starts from one end of the disk and moves towards other end and servicing each request until it goes to other end of the disk, and where the head movement is reversed and servicing continues. Let us say initially your head is at 53, now I'm moving from left to right. Now I'm moving from left to right. Now I'm moving from left to right. That is 53, and after that 37, and after that 37 to 14, but there is no guys are there, but still I am trying to search it where anyone is there, but no one is there, unnecessary seek movements here. And after that from 0 to next 65, 67, and after that I process 98 and 122, 124 and 83. So the total seek movements is 53 minus 37, 37 minus 14, 14 minus 0, and 65 minus 0, 67 minus 65, 98 minus 67, and 122 minus 98, 124 minus 122, and 183 minus 124. Altogether you can add it, you will get total track movements is 236. Okay, that is 236. This is scan scheduling. And next one, circular scan scheduling. You know what is circular? The head moves from one end of the disk to other, servicing each request, and it goes. When it reaches to the other end, however, it immediately returns to the beginning of the disk. It's simply acting like a circular cube. Now let us see. Okay. So treat all cylinders are in circular manner. Okay. Initially you are at 53. Now we are moving 67, 65. From that you are moving to 67. From that you are moving to 98. From that you are moving to 122. Then 124. Then 183 and 199. There is no. Now the disk is at ends. And after that again you will come back to 0. From 0 to next job is 14 and next one is okay 37. The total number of seek movements is equal to 65 minus 53, 67 minus 65, 98 minus 67, 122 minus 98, 124 minus 22, 122, 183 minus 124, 199 minus 183, 199 minus 0, and 14 minus 0, 37 minus 14. The total number of movements, if you calculate it, you will get 382 track movements. And after that, look scheduling. Why you are unnecessarily moving to the end of the disk if there is no jobs? Then how will you do it? Please don't try to move until the end. Why? In case if there is no jobs are left over there. Now how do you do it? 53. From 53, and that implies arms goes as far as the last request in the direction. Then it reverses the direction immediately without first going to the way at the end of the disk. Now we see from 53 initially it serves 65, and after that it serves 67. Next it is 98. Next 122, 124, and after that 183. There is no jobs after 183. That's why I'm moving return back from here. So I'm not going to the end 0. And why? Because the job is at 14. I will start from 14. After 14, it services to 37. Now I'm not moving towards the end of the arms. Now the track movements is 65 minus 53, 67 minus 65, 98 minus 67, 122 minus 98, 124 minus 122, and 183 minus 154. And after that, 183 minus 14 from 37 minus 14. All that you will get only 132 tracks. This is look scheduling algorithm. This is going to be called as look scheduling algorithm. And coming to the next very important is disk management. So disk management. What do you mean by disk management? So You know what is formatting? Already I defined in the third topic of discussion. Formatting is nothing but low-level formatting, or we call it physical formatting. Divide the entire hard disk space into tracks and sectors is going to be called it as, okay, formatting, or you may call it as fresh fact table creation is going to be called it as formatting. So you are creating a fresh fact table. Already I told you that the smallest representable unit on secondary storage devices is a sector. Okay, that is the first one. And second one is that, and next very important one is, so formatting is nothing but creating a fresh file system. Formatting a disk means that creating a fresh file system. Already I told you that in order to improve the efficiency of a disk access time, instead of going for a block at disk sector addressing scheme, you can go for a block addressing scheme. You can go for block addressing scheme. And coming to the next very important one is, okay, boot block. Okay, what do I mean by boot block? Boot block contains, or you may call it as zero track of your hard disk, but it contains bootstrap loader. A bootstrap loader is a program which knows that how to load the operating system into main memory. How to load the operating system into main memory. So bootstrap loader program is stored in boot blocks of the boot partition. Okay, so whatever the bad blocks are there, okay, which is detected by your error detection techniques, the blocks are going to be simply blocked. It cannot be used for accessing. It is the responsibility of the operating system. And coming to the last very important topic, the last technique but not least, okay, swap space management. Already we done this particular topic in the earlier. What is a swap space? Already I done virtual memory. What is virtual memory? Virtual memory is a concept which gives an illusion to the programmer that he has a large amount of memory, relatively having a small amount of memory. Even though if you're having a small amount of memory, it gives you a look and feel that you have a large amount of memory. You have a large amount of memory. So that implies, so we are going to be always seeing that which modules are currently required, it should be in memory, and which modules are not currently required, which is not back into secondary storage device. So in secondary storage device, where you are going to be capturing all these files, is called it as a swap space. Okay, generally this particular one is named with the temp directory. You can see with the file extension .swp, swap files or .emp files. The swap space can be, so the swap space management program is responsible for simply swap out the processes which is not currently required and bring back into main memory whenever it importance is comes. So which is always handled by context switch and dispatcher. We're going to look this. This kind of a program's collection is known as swap space, context switch, and dispatcher is known as swap space management. Okay, and in which area in the hard disk you are going to be storing all the swap files. These are all going to be called it as swap space. This is completes our discussion about your operating systems. Okay, and this is completely all the sessions has been completed. Okay, if any queries are there, you can put them in Google Sheet so that I'll make answers and I'll send you back. Thank you. Is anybody there? Yeah, the presentation is over. The sessions is over. Okay. Yeah, thank you. Inform your Satyanarayan Garu Dean. Okay.